In the last session, we finished our third unit that was based on thermal aspects in metal cutting. Now, today we are going to begin with the unit number 4, that is processing of powder metals. You might have heard this word powder metallurgy in the past, and this unit number 4 is going to be based on that powder metallurgy, various aspects related to powder metallurgy. So, before beginning with the content, let's go through the objectives of the unit. So we'll be beginning with the introduction of the term powder processing. So powder processing, or it is also called as powder metallurgy, the term indicates that we are going to use powder as a raw material, and we are going to compact it, heat it, and finally we are going to get the product from that powdered raw material. And this whole technique is called as powder metallurgy or powder processing. So we'll be discussing the introductory part. Then when you convert this raw powder into a product, what steps we are going to follow? That steps we are going to discuss. So that will be second objective, discuss the steps involved in the powder metallurgy. Third one, explain various methods of the powder production. So when I'm saying that the powder metallurgy is the conversion of metal powders into a product, but these metal powders are not going to be freely available in the nature, right? Whenever you extract any metal from the nature, it is going to be in its raw form. It will be in a form of compound. It will be mixed with some additional materials. It is not going to be in its purest form, right? So that raw material has to be converted into powders first. Its purity has to be, because it is going to be combination of more than one materials when you extract from the nature, and then it has to be converted into powders. So what are the methods for conversion of raw material into powders? That we'll be discussing. The next one, various methods for powder compaction. So once you have got powder, the next step, when you convert powder into product, there are various steps involved in between. And once you have got metal powders, the next step is going to be compaction of those powders. Compaction is nothing but when you provide a raw shape to a product before heating it, right? So this is going to be made from the powder and some binding materials. When you mix those together and when you provide its raw shape initially before heating it to its final temperature, that we usually call a sintering. So before sintering, we need to get this raw shape, and getting that raw shape is nothing but a powder compaction. Okay, and once you have done with that powder compaction, next step is going to be sintering operation, that is heating this raw shape to some elevated temperature. That temperature range could be dependent of the metal that you are using as a raw material or characteristics of the product. Depending upon that one, this heating temperature will be decided. So next step is going to be a sintering operation. So when you heat it at that elevated temperature, whatever binding materials that you have mixed in these raw powders, that will form bonds with the metal powders, and you will get the final characteristics of the product. Whatever final strength that we are expecting from the product, that will be available after the sintering operation. The next, discuss the post processing involved in the metal powders. Now, actually, when you apply this powder metallurgy, in most of the cases, the shape, size, dimensions that we get are almost near net shape. This is also called as near net shape manufacturing because the dimensions are almost close to the final dimensions. But still, in some cases, we need to go for post processing. So why do we need to go for post processing? The reason is when you uh, compact it in a wet shape or in wet condition, that is when initially you mix binding materials and powder together, and when you heat it to a elevated temperature during sintering, there is going to be some contraction in the shape because it has got some binding materials that forms bonding when you heat it at elevated temperature, and during that bonding and all there might be contraction in the shape, and to avoid that one there would be some dimensional tolerances provided initially, or in a design there would be some tolerances provided, and that extra material has to be removed. Or in some cases when you get product from powder metallurgy, the surface, whatever product you have got, the surface property may not be suitable for certain applications. We may expect some better surface finish from the product, and in that case we need to process it further, and those processes are called as post processing applications because these applications are applied after sintering or when product has got its final characteristics, and in that condition we are applying those operations. So these are post processing applications. Last second last one, discuss the design considerations in powder metallurgy. So when you want to apply powder metallurgy to get certain product, what care has to be taken, how powders has to be selected, how instrument has to be decided, how that operation has to be controlled, all these things has to be certain rules and regulations that has to be followed to have a better efficiency or better productivity. So those things are called as design considerations. And related to this powder metallurgy, whatever design considerations are there, that we'll be discussing. And last one, the commenting on capabilities and limitations of this powder metallurgy process or this metal powder processing techniques. Capabilities means what are advantages or what are uh, better characteristics compared to other processing techniques, and what are limitations associated with it. That all things will be discussing. Next, introductory part. So, how this metal powder processing techniques came into existence, or since when we started using it. Like other manufacturing techniques, this uh, powder metallurgy technique has been, or we are using this technique since like ages. If you try to find its roots, you will get it that this technique is being used 3000 before Christ. So it is like that much old techniques, or we are familiar with this technique since that time. And when it comes to uh, when it was used in that period, it was prominently used for making iron tools. So those days the people were using this powder metallurgy to make the iron tools. But when we started using it for some better applications, that was in early 90s when we invented the electric bulb. The filament of that electric bulb was made by using this powder processing technology. That was the first like advanced application of this powder metallurgy. In addition to that one, it has got certain better or some advantages that we can mention over here. The advantages are, as I mentioned earlier, the technique is offering near net shape forming. So the product that we get from powder metallurgy processing are almost of final dimensions. Okay, that is the first advantage. And second advantage, this technique can be applied to a variety of metals. If you can get metal powder, then you can apply this technique to that material. So by using this technique, you can use or you can apply this technique to variety of materials. Like there is no limitations as such. So you can use various metals and you can form near net shape product. So that way, that losses, time consumption in further processing and all that could be reduced. So that way, this has got a better economic perspective. Or if you look at this process economically, this is going to have better characteristics compared to other processes. Now, what are the typical products made by this powder metallurgy? There are various products, but here some prominent or some important products has been mentioned, or which products are uh, typically made by this technique. The techniques, the products are like connecting rod, piston ring, gears, cams, bushings, bearings, cutting tools, then some magnetic products, metal filters, and even in surgical implants. Because if you are going for some medical surgery to replace some joint from our body, the parts are usually made up of powder metallurgy. Okay, there are certain alternative techniques to this powder metallurgy, or if you want to replace this powder metallurgy, then what are the processes that you can go for? The first one is casting, then forging, and even machining. Machining we are very much familiar about now because we have seen first two units on second and third unit on this machining itself. Additionally, casting and forging is there that you might have seen in the MP1. So these are the alternative processes, and in the sketch shown over here, you can see some of the examples of the powder metallurgy process product. Out of all these, this product you might be familiar with, right? If you have farm and if you have seen that sprinklers, the nozzle of that sprinkler is shown over here, and that has been manufactured or that has been processed by powder metallurgy technique. Next. Now, in addition to examples that we saw over here, there are some more examples that we can discuss, and these examples are like balls for point pen, then automotive component, then tools, then magnetic product, metal filters are there, metal foams are there, surgical implants are there, then aerospace, nuclear, industrial applications. There are various products in these fields that are made up that are processed using this powder processing technique. Now, as I mentioned, this technique can be applied to variety of materials. As long as you can get powder from that material metal, you can apply this technique. But the prominently processed metals are, or widely used metals are, iron, copper, aluminium, tin, nickel, and titanium. These are the metals that are widely processed using this powder metallurgy to produce various parts made up of these materials. Additionally, some refractory metals are also processed by using this powder metallurgy. Refractory metals are the metals that can withstand its properties even at elevated temperature, and because of that characteristics, these metals are used in refractories. So those metals are, or that group of metals are called as refractory metals. Next, when it comes to applying this technique to brass, bronze, steels, stainless steels, in such cases, pre-alloyed powders are available, and that pre-alloyed powders are used as a raw material. Now we know that what is mean by alloying and all, right? Alloying is nothing but mixing of more than two materials together to have certain specific properties. Now, when you want to get a product having some specific properties, either you can add those materials together at the time of processing, or you can get pre-alloyed powders also. So when you produce powders from that metal, at the time of production of powder itself, you can mix various materials together and you can have that alloy powders. Okay, that is also choice available with us. Now, raw materials used. So when you want to produce metal powders, what are the raw materials available? As I mentioned earlier, the metals available in the nature are not going to be in its pure form. That is usually mixed with some other materials, and you will get it in the form of either alloys or salts, or in the form of compounds where more than one materials are mixed together. If you take an example of iron or copper, it will be available in the form of oxides like iron oxide, copper oxide, etc. That is combination of that iron and oxygen. That is nothing but the oxide of that particular material. So that way it will be available in the raw material in the nature, and that has to be extracted and then converted into powders. Now here we are going to take a look of a sequence of operation that is going to be followed in this powder metallurgy or powder metal processing. The operation is going to begin with the powders. So first stage is going to be metal powders. Now, to get that metal powders, these are the operations available with us, or these are the techniques that you can use or that you can apply for the conversion of a raw material into metal powders. So techniques like atomization is there. That is not automation, right? The automation and atomization are going to be some two different things. I have seen many people getting confused between those two terms. So it is atomization, then the chemical reduction is there, electrolytic deposition is there, carbonyl formation, then comminution, and mechanical alloying is also there. So these are the various techniques. We are going to discuss all these techniques in details in upcoming slides. But at the moment, these are the techniques that you can apply for the conversion of raw material into a metal powder. Okay. Now, once you have got metal powder, next step is blending. So, what is blending? The raw material or metal powders has to be mixed with some additional materials that are going to be required to have some specific properties in the final product, or that are required for have better processing characteristics. So when you are compacting the mixture to have that better compaction, whether it is hot or cold compaction, To have that better compaction characteristics, some materials are added to the powder like lubricant. Okay, so there are certain materials that are mixed into the metal powder, and then a uniform mixture is formed by applying certain techniques, and that operation is called as blending. So we got metal powders, we took some additives and lubricants, and we are mixing them together. And once we have got that mixture, now the next technique is forming a raw or green shape, because this is still at the its initial stage. We haven't heated it to its final temperature to get the final characteristic. So it is still in its raw form, and that uh, we are offering its shape in its raw form itself. That operation is called as compaction. Now that compaction could be at room temperature, called as cold compaction, or it could be at certain elevated temperature, called as hot compaction. If it is hot compaction, technique available is isostatic pressing, and if it is cold compaction, the techniques available are pressing, isostatic pressing. Isostatic pressing is available in both the cases, just temperature variation would be there. Then rolling is there, extrusion is there, injection molding is there. These are the techniques that you have seen in metal forming. So same techniques are applied over here. So here we offered the shape of the product by using these compaction techniques, and product that we get over here is called as green part or green product. Why we are calling it green? Because it is still in its raw form. It doesn't have got its final properties. That properties it will get once it has undergone the sintering operation. That is the next operation after compaction. Now this sintering is nothing but heating this green part to a certain elevated temperature. That temperature range will be dependent of the metal powder that we are using or characteristics of the product that we are expecting. Now that sintering could be taking place at atmospheric condition or in presence of atmospheric air, or in some cases it will be carried out in vacuum also. And after sintering you will get the product with its final properties. And as I mentioned here, in some cases we need to go for some secondary and finishing operations. The need of applying these operations is the surface characteristics that we expect from the product. The product that you have produced using this powder metallurgy technique might not have that fine surface that is demanded by the application, and in that case we need to go for post processing. Additionally, there could be some projections, so there could be some connecting parts together, and that has to be removed while or before putting it into actual applications, and that could be done using these secondary and finishing operations. So what are the finishing operations available with us? Coining is there, forging, machining, heat treating, impregnation, infiltration, and plating. So all these operations are part of secondary and finishing operation. So process begin over here with metal powders, and final step is going to be uh, secondary or post processing operations. Any doubt, any query in this or till the points that we have covered? If you have any, unmute and let me know, or put it in chat window. Okay, should I proceed further? Okay, next, production of metal powders. So now here we have discussed the various steps available associated in the metal powder processing, and now we are going to discuss individual step. So first is going to be getting the metal powders. Now before talking about the techniques that are used to get the metal powders, let's discuss the characteristics of the metal powder. So there are various techniques, and individual technique is going to provide different shapes of the powders. If you want to have these elongated particles, the technique available is chemical decomposition. If you want to have these irregular rod-like shapes, then either you can go for chemical decomposition or mechanical comminution. If you want to have this flake-like structure, then mechanical comminution is there. If you want to have this dendritic structure, then electrolytic decomposition is there. When you want to these spherical particles, then atomization is there, or precipitation is also there. Similarly, for these kinds of shapes, what techniques that you can apply has been mentioned over here. Now individual shape has got its own limitations as well as uh, advantages also, that we'll be discussing in the upcoming slides. But these are the various shapes of powders that you can get, and the technique that you can apply to get that particular shape. Now, the first technique that is widely used to get the powder metal is atomization. Now, what we do in atomization, there are four methods that has been shown over here in this sketch. The difference between all those techniques is, the first technique is based on air. The working fluid used is air. In the second techniques, water is used as a working fluid. In third one, mechanical force is there. That is, we are providing some mechanical movement that is rotating that disc. And third one is also similar, but here instead of rotating some disc or some additional part, here we are rotating the part which is being melt. Let's discuss all these techniques one by one. Let's begin with the first technique. So what we do in first technique, here in this assembly, this holds a molten metal. That molten metal will be produced by using uh, any of the available technique. That molten metal will be brought to this assembly and pour into this assembly through the opening at the top. When that molten metal starts flowing and it reaches in this region, there will be an arrangement made through which a high pressurized air jet will impact on this flow of molten metal. So molten metal is flowing down through this assembly, and when it reaches over here, it will be impacted by jet of high pressurized air, and because of that one, what will happen, the flow will disturb, and it will be disturbed into particles. And when those particles fall down, they will cool down, they will solidify, and you will get a particles. Now we saw over here, when you want to have spherical particles, the technique available is atomization. And we are discussing this. All these are the atomization techniques. So why do we get spherical particles in all those techniques? The answer for this one is, whenever a liquid, it is molten metal, so it is liquid. Whenever liquid is held in a space, it is not in contact with any of the body, it is freely suspended in a space, right? So whenever a liquid is suspended in a space, it try to minimize its surface area. The reason behind is surface tension available, right? Because of the surface tension, the liquid drop will try to minimize its surface area, and sphere is going to have minimum possible surface area. If you compare this particle, this irregular, this dendritic, or some angular particles, out of all these particles, sphere is going to have minimum surface area compared to its volume. If you take volume of this particle or this particle and compare with spherical particle, if all these have same volume, the spherical particle is going to have minimum surface area. And that's why whenever a liquid is held in space, it is going to be get the spherical shape. So in the first technique, we have used a jet of high pressurized air to disturb the flow and disturb it in the form of particles. So that particle will settle down and you will get the powder of that particular metal. Now, when you replace this air spray with a high pressure water spray, you will get the another technique.